The latest data from the James Webb Space Telescope has uncovered evidence of past life forms on the enigmatic planet Mercury. However, this discovery is just the tip of the iceberg, as researchers now suspect that Mercury may be far more mysterious than previously thought. For a long time, scientists believed Mercury was too hot to support any form of life, but recent findings are challenging this view. Mercury is a rocky planet, slightly larger than the Moon but much smaller than Earth or Mars. It was once considered too hot to harbor life or even any form of liquid, but the detection of water deposits on Mercury is changing our understanding of this world. The James Webb Space Telescope's observations are at the heart of this breakthrough, suggesting that Mercury has hidden secrets that were previously overlooked. Contrary to earlier assumptions, Mercury is not the hottest planet in our solar system. Although it is the closest planet to the Sun, with a distance of only 58 million kilometers, about 36 million miles, it is not the hottest planet. That title belongs to Venus. While Mercury's surface temperatures can soar up to 427 degrees Celsius (800 degrees Fahrenheit) during the day, they plummet to -173 degrees Celsius (280 degrees Fahrenheit) at night. This extreme temperature fluctuation occurs because Mercury has no atmosphere to retain heat. Mercury orbits the Sun at a breakneck speed of 47 kilometers per second, completing a full orbit in just 88 days. This rapid movement is due to the planet's proximity to the Sun, resulting in significant gravitational pull. The planet's surface is marked by various geological features, including large craters and cliffs that suggest an active past. These features, such as the massive Caloris Basin, which spans over 1,500 kilometers, 930 miles, in diameter, tell the story of a planet shaped by significant impacts and internal geological activity. Mercury's surface also shows signs of contraction, indicating that the planet has cooled over time. One of the most intriguing discoveries on Mercury involves the presence of water ice at its poles. Despite its extreme temperatures, researchers have found water trapped in the shadows of craters, where it remains frozen. This finding challenges the long-held belief that Mercury is too hot to store water. Mercury's extreme temperature variations make it a planet of extremes, but recent studies suggest there may be areas where conditions could support life, albeit in very limited zones, such as deep craters or beneath large cliffs where temperatures are more stable. Mercury has fascinated astronomers for centuries. The ancient Greeks were the first to observe this tiny planet in the sky, but it remained a mystery for much of human history due to its close proximity to the Sun. In the 17th century, advancements in telescopic technology allowed scientists to study Mercury in more detail, but it wasn't until the 20th century that our understanding of the planet took significant strides. In 1631, French astronomer Pierre Gassendi observed Mercury transiting the Sun, and in 1771, German astronomer Johann Hieronymus Schröter studied the planet's rotation. For many years, scientists believed that Mercury had a locked rotation, similar to the Moon's synchronous orbit with Earth. However, in the mid-20th century, it was revealed that Mercury's rotation was much slower than previously thought. In the 19th century, astronomer Urbain Le Verrier proposed the existence of a hypothetical planet between Mercury and the Sun, which he named Vulcan, to explain unusual anomalies in Mercury's orbit. Despite numerous searches, this planet was never found. In 1915, Albert Einstein's theory of general relativity explained the observed orbital anomalies, eliminating the need for Vulcan. The first true images of Mercury came from NASA's Mariner 10 mission in the 1970s. These close-up photos revealed the planet's surface in greater detail than ever before, including its craters and other geological features. Mariner 10 flew past Mercury multiple times, providing valuable insights into the planet's surface and atmosphere. The latest revelations from the James Webb Space Telescope are set to further transform our understanding of Mercury and our solar system's smallest planet. NASA has extensively studied Mercury, uncovering that it lacks a true atmosphere, instead possessing only a thin exosphere made up of helium and hydrogen. For many years, NASA refrained from sending missions to Mercury, citing the challenges posed by the planet's proximity to the Sun. The extreme conditions and strong gravitational pull from the Sun made it difficult to send probes that could withstand such harsh environments. It was only in 2008 that NASA's Messenger mission ventured to Mercury again, marking a new chapter in its exploration. The Messenger spacecraft entered Mercury's orbit in 2011 and, by 2015, had provided groundbreaking insights into the planet's surface, geological history, and even evidence of volcanism and water ice at the poles. These discoveries sparked new interest in Mercury, revealing that the planet might have been more dynamic than previously thought. Scientists even speculate that Mercury could have once existed in a different part of the solar system, potentially in the habitable zone, and that it might have even harbored life in the distant past. Some of Mercury's geological features suggest that it could have resembled a more Earth-like world, or even Mars in its early history. The James Webb Space Telescope, JWST, is now set to provide fresh insights into Mercury, offering new tools to study planets like Mercury and other gas and ice giants. The JWST's advanced imaging capabilities will allow scientists to analyze Mercury's surface and atmosphere in detail, and it will be able to distinguish the planet's reflected light from the overwhelming glare of the Sun. This will provide unprecedented data on Mercury's chemical composition and its potential for past geological activity or even the presence of life-supporting resources. One of the most intriguing discoveries so far is the presence of water ice in Mercury's permanently shadowed polar craters, which challenges the assumption that the planet is too hot to support water. These findings open up new possibilities for future missions and suggest that there may be more to Mercury than we initially thought. Despite its small size, Mercury's surface is marked by impact craters, volcanic features, and signs of past geological activity. The planet's exosphere is primarily composed of hydrogen, with trace amounts of other gases, and it lacks a significant atmosphere to regulate temperatures. As a result, Mercury experiences extreme temperature fluctuations, with daytime temperatures reaching up to 427 degrees Celsius (800 degrees Fahrenheit) and nighttime temperatures plummeting to -173 degrees Celsius (-280 degrees Fahrenheit). Mercury's fast orbit around the Sun, completing a full revolution in just 88 Earth days, combined with its slow rotation, creates unique day-night cycles. The harsh environment has made it challenging for space agencies to explore the planet. The Mariner 10 mission in the 1970s provided the first close-up images of Mercury, revealing its cratered surface. Subsequent missions, including Messenger, have expanded our understanding of its geological makeup, magnetic field, and exosphere. Now, with the JWST's high-resolution imaging capabilities, scientists are poised to gain even deeper insights into Mercury's surface and its potential for containing water or other volatile compounds. By observing the planet as it passes in front of the Sun, the JWST will gather invaluable data, helping to further unravel the mysteries of this enigmatic world and its place in our solar system's history.